This is lesson 2.1, writing and graphing inequalities. You should be on page 54. In this lesson, you will learn how to write a linear inequality, how to sketch the graphs of linear inequalities, and how to write linear inequalities from graphs. Let's talk about writing linear inequalities first. Vocabulary, we should get this in our notes. An inequality is a mathematical sentence that compares expressions. An inequality contains the symbol less than, greater than, less than or equal, or greater than equal. So that's how an inequality is different than an equation. An equation is comparing two things that are equal. An inequality is comparing two things that are not necessarily equal. To write an inequality, look for the following phrases, and these are things, again, I would definitely get these phrases below in your notes to determine what inequality symbol to use. This symbol is a less than symbol. If you read is less than in a problem or is fewer than, that's the symbol that you should be using. I should point out real quick, remember, if you read the words less than means subtract, but is less than, you notice the word is in there, is less than is an inequality. So I want to be clear, less than means subtract, but is less than would mean inequality. Okay, so sometimes those two get confused. This symbol is the greater than symbol. The words is greater than or is more than would indicate that. Or this is the less than or equal to symbol. Is less than or equal to, or is at most, or is no more than is the symbol for this, or the words to represent that. And finally, the is greater than or equal to symbol. Is greater than or equal to, is at least, and is no less than would all be words that describe that symbol. So let's talk about writing inequalities. Let's write in each sentence as an inequality. So you notice here, a number w minus 3.5 is less than or equal to negative 2. So you can see below what they did was let me take a highlighter here. A number w minus 3.5, well, they wrote it right here. W minus 3.5 is less than or equal to, that would be this symbol, and you can see that here, negative 2. So you can see how they wrote that right there. W minus 3.5 is less than or equal negative 2. Or the next one, 3 is less than. So the number 3 is less than a number n plus 5. Well, there's n plus 5. So 3 is less than n plus 5, and you can see they wrote that there. Or here's a third example. 0 is greater than or equal to. There's the symbol for greater than equal to. There's 0. 0 is greater than or equal to twice a number x. That means x times 2 plus 1, which you see here. There's the entire statement. 0 greater than equal to x plus 1. Why don't you pause the video and try these yourself? And I'm back, and for question 1, a number b is fewer than 30.4. You should have this. B is less than 30.4. Or on number 2, negative 7/10 is at least twice a number k minus 4. So here's negative 7/10 is at least twice a number k, which means doubling k, subtract 4. Let's talk about sketching the graphs of linear inequalities. And we have some more vocabulary we got to get in our notes first. A solution of an inequality is a value that makes the inequality true. So I would get that in there first. The solution of an inequality is a value that makes the inequality true. Let me give you a simple example of that. Let's say we had the inequality x is greater than 10. A solution would be a number that I can plug in here that makes this true. Like if I put a 20 in there, 20 is definitely bigger than 10. 20 is a solution of the inequality. Now it's important to note, an inequality can have more than one solution. There's a whole bunch of numbers I could plug in here that are bigger than 10 and would make it true. The set of all solutions of an inequality is called the solution set. So this inequality that I showed you would have a large solution set. There's a whole bunch, there's an infinitely number of correct solutions that would be bigger than 10. Okay? Let's look at the sample first before I guess I talk about this. Here would be a sample. X plus 5 is greater than equal negative 2. They're asking me, is negative 6 a solution? Let's try it. If I put negative 6 in here, negative 6 plus 5 is negative 1, and the question is negative 1 bigger than negative 2? Well, think about a number line. Negative 1 is definitely farther right on the number line. So yes, this is true. Negative 6 would be a solution. If we try negative 7, negative 7 plus 5 is negative 2, and is negative 2 greater than or equal to negative 2? Now remember, the key word is or. Or means if one of them are true, it's a true statement. Well, negative 2 is equal to negative 2. That is true. So yes, that's a solution. Now if I try negative 8, negative 8 plus 5 works out to negative 3, and if you think of a number line, negative 3 is not to the right of negative 2, so this one, no, this would not be a solution. So when they ask you to check to see if a number is a solution, that's all they're asking you to do. Plug it in and see if it makes the statement true. Now it's important to note that if you have a diagonal line through an inequality symbol, that means the inequality is not true. For instance, this greater than equal symbol with a slash through it would mean is not greater than equal to. Like here would be an example of that. 10 and 15. 10 is not greater than equal or equal to 15. So I'd put a slash through this because this is not true. 10 is not greater than or equal to 15. Okay? Let's quickly try these down here. Tell whether negative 4 is a solution of the inequality. Let's try it. You can see they did that here. They took negative 4 and they plugged it in for x right here. So they have negative 4 plus 8, which is 4, and is 4 less than negative 3, and the answer is no. So 4 is not less than negative 3. So 4 is not a solution to this inequality. I misspoke. Negative 4 I meant to say. Negative 4 is not a solution to the inequality. Okay? Let's try negative 4 for this inequality. So if I take negative 4 and plug it in here, so negative 4.5 times negative 4 would give me positive 18. And here's the question, is positive 18 then greater than negative 21? And well, yeah, it's farther right. So this is true. 18 is greater than 21, so negative 4 is a solution of this inequality. I want you to go ahead, pause the video. Why don't you try these 4? I need you to figure out, is negative 6 a solution of the inequality? Okay, we're back. For question 3, I plugged a negative 6 in for C. Negative 6 plus 4 is negative 2, and the question is negative 2 less than negative 1? And yeah, it is. So that's true. I put a little check mark here. This would be true. It is a solution. Yes. Okay. Number 4. If I plug in negative 6 for M, oops, I see I screwed up there, negative 6. So 3 minus negative 6 would be a 9. Is 10 less than equal 9? No, that's not true. 10 is bigger than 9, so this is not true. So no, negative 6 is not a solution there. if I plug negative 6 in for 5, 21 divided by negative 6 is negative 3.5. And my question is negative 3.5 greater than or equal to negative 3.5? Yes, it is. It's equal to it. It's one of those. So this would be true. And if I plug in negative 6 here, 4 times negative 6 is negative 24. If I take away 25, I get negative 49. So here's the question. Is negative 49 greater than negative 2? And no, it's not. So that's not true. Negative 49 is not bigger than negative 2. Okay? So hopefully that's pretty easy. When you're asked to check if if a number is a solution to an inequality, it should be as simple as you taking the number, plugging it in the statement, and seeing if you get a true statement. Let's talk about the graph of an inequality. The graph of an inequality shows the solution set of the inequality on a number line. Now, when I was your age, I hated graphing because I thought it was just extra work, but here's what you have to understand. Graphing is actually a shortcut. And you might be like, what do you mean? Well, think about this. If I said, go home tonight, and I want you to write down every answer to this inequality, does it make sense? You'd never get it done. But if I said graph the solution set, that would be easy. You could go to a number line. Let's do that. I'm going to go to a number line real quick. And while it would be impossible for me to write down all the solutions, this would be easy graphing it. Okay, I want all the values where x is greater than 1. Well, I'll have an open circle at 1, and I'll just shade everything right of that. And there is symbolism that shows all the numbers that would be greater than 1. It took me a few seconds. It would have taken me forever to list them all. Graphing is actually the shortcut. And I will even make sure that when you do graphing, I give you graph paper up front to make your work easier. So the graph of an inequality, it shows the solution set of the inequality. Now we got to be careful. An open circle is used when a number is not a solution. You notice in my last example, 1 is not a solution. That's why I used an open circle. 1 is not bigger than 1, but everything to the right of it is. A closed circle is used when a number is a solution. And you use an arrow to the left or right to show that the graph continues in that direction. Let's look at these real quick. So they have graph each inequality like y less than equal negative 3. So you can see they put a closed circle at negative 3 because negative 3 would be a solution. It equals. And then I'm going left of that, and you can see an arrow shaded to the left. So that would be a picture of y less than equal negative 3. Now let's go to the second one. 2 less than x. We have an open circle at 2 because we can't plug in 2. 2 is not less than 2. That's not true. So open circle 2. I want 2 less than these numbers. So if 2 is smaller, the other numbers have to be bigger. So I'm shading right of that on my number line. And you can see the picture of that for this one here. And then finally, x greater than 0. So we have an open circle at 0, and we're shading right of that. You can see an arrow shading right. What I need you to do right now is I would like you to actually try these real quick. Try these. Okay, I'm back. So for 7, b greater than negative 8. So I have an open circle at negative 8, and b is greater. So here are all the numbers greater than negative 8. You can see my arrow pointing right. Question 8. 1.4 is greater than or equal to g. So you can see I have a closed circle at 1.4 because it's equal. Now 1.4 is bigger than these numbers. So you see the other numbers must be smaller. I'm shading left. So here are all the numbers that 1.4 is bigger than. Number 9, r is less than a half. So open circle at half. R is less than that. I want all the values less than a half. That's why I'm shading to the left. And question 10. V is greater than equal square root 36. So the square root of 36, I hope we know, equals 6. So V is greater than equals 6. So I have a closed circle at 6, and I'm shading to the right. Okay, so final part here, we want to be able to write a linear inequality from a graph. So here would be an example. The graphs show height restrictions in inches for 2 rides at an amusement park. Write the inequality that represents the height restrictions. So you can see we have a closed circle on ride A at 48, and we're shading right. That means my unknowns have to be bigger than or equal to 48. Okay? Now, okay, they used H, I used X, let me make that H. And you can see that matches what they have here. Or in this one, ride B, we have an open circle at 52. That means 52 is not a solution. And since we're shading left, that means all the numbers less than 52 are solutions. So I would want H is less than 52. Okay? This write an inequality that represents the graph. It looks like to me, if I'm looking carefully, we have a closed circle at -6, which means that is a solution. And I want all the values that are equal to or bigger than that, so X would be greater than equal -6 for this. I'm going to stop the video here. If you have questions, make sure you ask in class.